So Unit 2, we're going to focus on basic algebra, more problem solving, and then some of our measurements and working with measurement conversions. So our first step is to look at things that look like this. It's an equation. The key to understanding an equation is that symbol right there, which of course is the equal sign. The big question is, what does the equal sign mean? It's really hard to go ahead. Okay, it's really hard to define it without using the word equals, isn't it? And yeah, it means that x is exactly the same as 7. It's saying that whatever's on one side has exactly the same value as what's on the other side. In fact, you can think of it kind of like a balanced scale. What's on the left side exactly balances what's on the right side. Now, all equations start out in this form right here, is a variable equals a number, or a number equals a variable. And they are built up from there. So things we can do to build up these equations are our basic operations. Addition, subtraction, multiplication, division, powers and roots, and there are other operations like exponents and logarithms that we're not going to get into in this course. But any of those basic operations can be used to build up this equation. So let's just go ahead and do that. Let's do addition, and we're just going to pick a number. I'm going to pick the number 4. So I'm going to add 4 to build onto this equation. So this is now x plus 4. Now the way I have it right there, though, if I added 4 there, this equation is going to tip unless, or this scale, I should say, is going to tip unless I do what? Yeah, unless I do exactly the same thing to the other side. So I must also add 4 to the 7 on the other side. So that keeps that scale balanced. So we have now built up this equation to be a little bit more complicated than where it started. Generally, we are not asked to build equations. What we are asked to do is solve equations. And that command, solve, what they're asking us to do is to take that equation apart and get it back to this form. Well, this equation was built by adding 4. How would we take it apart? What's the opposite of adding 4? Subtracting 4. Very good. So we subtract 4 to take that piece off. Now, just like up here, if we don't do exactly the same thing to both sides, the scale is going to tip. So we subtracted 4 on this side. We have to subtract 4 on this side. 11 minus 4 is 7. So now we're back to that form. The variable equals a number. So x equals 7. So that's saying, in this case, x has the same value as 7. And as we keep moving ahead into more complex equations, that means that we can take out the x and replace it with 7. Now this equation here, we built it. So we knew how it was built, so we knew how to take it apart. So the next step is to figure out how do we look at an equation and figure out how it was built. Well, there's a series of steps we go to for that. First thing we do is we identify where the equal sign is. Of course, that's right there. Next, we identify what side of the equation has the variable. So step 1 is find the equals. Step 2 is find the variable. Step 3, we're going to ask ourselves, what is keeping the variable from being alone? Or from being by itself on that side of the equation. And in this case, it's the 8. Now, part of that question 3 is what operation was used to attach it. So we know that the 8 was built onto this equation at some point. Otherwise, the variable would be by itself. What operation was used to build that 8 onto this? Well, it was subtracted. The 8 has been subtracted from y. So this equation was built by subtracting 8 from our variable. Well, how do we remove subtracting 8? We add 8. The opposite of subtracting 8 is adding 8. So it takes that piece off and leaves us with just y. Now again, like we said over here, to keep this thing balanced, we have to do the exact same thing to each side. So we added 8 over here. We have to go over here and add 8. 5 plus 8 is 13. So we get that equation down into its simplest form. A number equals a variable. 13 equals y. Now what that is telling us is, as I said, that y has a value of 13, or wherever we see y, we can replace it with 13. So I'm going to rewrite this original equation up here. But instead of putting in y, I'm going to put in 13. So instead of y minus 8, I'm going to put in 13 minus 8. And this is how we double check to make sure that this answer works. We should get the same value on each side. Well, 13 minus 8 is 5. So we do have the same value on both sides of the equation. So that's telling us we're relatively assured that answer is correct. This one's a little bit trickier because we don't see the operation. But if we go through the process, here's our equal sign. Here's our variable z on the left side. What's keeping that z from being alone? The 7, and it was multiplied. There's no operation there, but when there's a number in front of the variable, that's implied that it's multiplied. So it's 7 times z. So how do we get rid of multiplying by 7? Divide by 7. Good. So we divide by 7, and that's gone, leaving us with z. Now, as always, whatever we do to one side, we have to do to the other. So we have to divide by 7 over here. 35 divided by 7 is 5. And of course, we can go back in and replace z with 5 and make sure that this is true. So 7 times z becomes 7 times 5. And of course, yes, that does equal 35. Well, they don't stay that simple. It would be nice if they did. But we end up with things like this. So here, we find our equal sign. The left side is where our variable is at. But this time there are 2 pieces that have been built on this equation. 2 things that are keeping my variable from being alone. So it feels like one of those days, doesn't it? My alarm went off this morning and I felt like I could roll back over for the rest of the day. What has been done to our variable, to x in this case? Well, we have the 5 and the 8 there. What operation is attaching the 5? Multiplication. The 5 is multiplied. The 8 has been subtracted. Now, don't worry about solving the equation right now. Think about order of operations. Order of operations, what would you do first? Would you multiply or would you subtract? Multiply. So what that is saying is when this equation was built, the first thing that happened to the variable is it was multiplied by 5. Then the 8 was subtracted from it. Now, if you think about it, let's say you put something together. Whether it's a piece of furniture, a toy for a kid, whatever you do. You've just finished it and you've just put on that last piece. If you need to take it apart again, what piece are you going to take off first? The last piece you put on, exactly. The exact same thing goes for equations. we have to take off the last piece first. You do it in reverse order. You go back through the instructions and you go backwards to take it apart. So subtracting 8 is the last piece that was put on here. That's the first piece we have to take off. How do we take off subtracting 8? Adding 8. And of course, we have to do that to both sides. So over here, all that's left is the 5x. Over here, we have to do 22 plus 8 is 30. Now, all that's left is to get rid of the 5. How do we do that? Divide by 5. So the 5's gone. Dividing the 30 by 5 makes 6. So x equals 6. And again, we can go back to the original problem and replace x with 6. So 5x becomes 5 times 6 minus 8. And we need to check, there's 22 on the right side, so we need to check to make sure we come out to 22. 5 times 6 is 30. 30 minus 8 is 22. So we get the same value on both sides of the equation. The scale is balanced. Have you guys try one? I'll give you a, oops, helps if I give you one that works out well. Give you guys a couple minutes to do that one in your notes. So what is the first thing we have to do to take this apart? To subtract 2, very good. So subtracting 2 over here as well gives us 27. Over here, all that's left is the 3x. What's next? Divide by 3, very good. So 27 divided by 3 is 9. Here the 3 cancels out and we just have x. And of course, if you wanted to, you take that 9, put it back in for x, and make sure you get the same value on both sides. Well, things can get more complicated, mainly like this. So here, we find our equal sign. We go to identify where the variable is, and we see the variable occurs twice. X is in there twice. But now, if we're thinking about that balanced scale, we see both the 3x and the 2x are on the same side of the equation, or on the same side of the scale. So the question I'm going to propose to you is, can I take that 3x and that 2x and push them together into one big pile? Would that change how this equation balances? It shouldn't, right? They're both on the same side. So I can take 3x and 2x and put them together to get 5x. So 5x minus 7 equals 23. Again, I was only able to do that because the 3x and 2x were on the same side of the equation. They're on the same side of the scale. Now, of course, what do I do to solve this? Add 7. So 5x equals 30. And then divide by 5. So x equals 6. And again, we could always go back, and instead of 3x, that's 3 times 6, minus 7, plus, instead of 2x, it's 2 times 6, equals 23. 3 times 6 is 18. 2 times 6 is 12. 18 minus 7 is 11, plus 12 is 23. So we get the same value on both sides. So again, we're relatively assured that we did have the right answer there. Here, however, it's a different story. Can I just push the 5x and the 2x together to make a big pile here? No. Well, we just said in the last one that we could. So what's different about this one? Yeah, here's our equal sign. The 5x is on the left side, and the 2x is on the right side. They're not on the same side of the scale. I can't just push them together because they're not together. So what we have to do is just get rid of one of them. When we're solving equations, we cannot begin this solving process of taking the equation apart until we've got it combined down to a single appearance of the variable, to a single variable. So that's the first thing we always have to do. So here we have to either get rid of the 5x or the 2x. It is usually easiest to get rid of the smaller one. So which one's smaller here? 5x. So to get rid of it mathematically, to get rid of something, we subtract it if it's positive or add it if it's negative. So we subtract 2x, leaves us with 28 over there. But we have to do the exact same thing on the left side. Now remember, when we add or subtract, we can only combine things that have the same name, the same label. So the only place we can take the 2x away from is the 5x. So 5x minus 2x is 3x. But we do still have that positive 7, plus 7 there. Now that we're down to just a single appearance of a variable, so what are we going to do? Subtract 7. So 3x equals 21. And then divide by 3. Good. So x equals 7. And again, we could plug that back in to double check. 5x becomes 5 times 7 plus 7 equals 2x becomes 2 times 7 plus 28. So 5 times 7 is 35 plus 7 is 42. Notice I can work on each side of the equation separately. I don't have to handle the whole thing at once. So the left side becomes 42. On the right side, 2 times 7 is 14. Plus 28 is 42. So we get the same value on both sides. It tells us that that's most likely the correct result. What sticks out as being different here? Parentheses, right? Whenever we see parentheses, it should scream at us, do something here first. Now, parentheses can be one of two things. They can be an enclosing symbol, which is telling us we have to do what's inside of this thing first. Now, in this case, is there anything inside here that we can do? No. 3x minus 5 is not, it's nothing we can do. So that means this parentheses is the second one. It is just a separator. So what it is doing is separating that number, the 3x minus 5 is really a single number, from the rest of the problem. Remember, we did that with some of our negatives as well. We put them in parentheses to keep them separate. So if there's nothing to do inside the parentheses, then we have to ask, is there anything that needs to be done to the parentheses? And in this case, there is. It's being multiplied by 7. So 7 times 3x minus 5, you can think of 3x minus 5 as really just a single number. Just like you would multiply any other whole number, you have to multiply every digit by the 7. So 7 times, this is really a negative 5, is negative 35. 7 times 3x is 21x. Now, most of you are probably shown a process that's a shortcut of this called distributing, where you just do this. 7 times 3x is 21x. 7 times negative 5 is negative 35. Does that look more familiar? Yeah. This here is really the long process, the whole thing that's going on there. But they developed this distributing here because it takes up less room and it's quicker. And you can see it puts us into an equation right below it that we're ready to just keep working with. Is there anything else we have to do to that before we start to solve it? Okay. Yeah, now we're down to where we can go ahead and start to solve it. So we are going to add the 35. Get rid of it there, and adding 35 here. So that's gone. 21x is all that's left on the left. 70 plus 35 is 105. So now to solve for x, we would divide by 21. So x equals 5. And again, you could go back and replace that x with 5 and work everything out to verify you get the same value on each side. So we look at something like this. Combines a few of the things we've been dealing with. We see the parentheses, so that means we do have to do something with them first. Now the equal sign is in the middle here, so I can work with one side of the equal sign first and then go over to the other side and simplify stuff over there. On the left side, is there anything I can do inside those parentheses? No. So how about 2 of the parentheses? Yeah, times 3. So 3 times 5x, 15x. 3 times negative 3, or 3 times negative 2, sorry. Negative 6, and then we still have the positive 11 there. Now before I move over to the other side, is there anything else I can do to combine or simplify that? Negative 6 and 11 makes positive 5. So the left side of this becomes 15x plus 5. On the right side, I see parentheses. Is there anything to do inside the parentheses? No. 2 of the parentheses? Multiply by 5. So 5 times 3x? 15x. 5 times 1? 5. So now I see that there is an x on each side. What do I have to do? Get rid of one of them, right? Of course, they're both 15x, so what happens is I subtract and the 15x disappears. I'm left with 5 equals 5. The variable disappeared on me. When the variable disappears, there's one of 2 possibilities. Possibility 1. Is this true? Does 5 equal 5? Yes. What that means is the variable x in this case can be any number. I can put any number in here for x and this equation is going to work out. Now a different possibility would be like this. If I go to solve this and I simplify the left side, nothing I can do in the parentheses, so I'm going to multiply by the 7. 7 times 4x, 28x. 7 times negative 3, negative 21. Now that's all I can do on the left side, so we're going to go over to the right side. Nothing to do in the parentheses, so we're going to multiply them by 2. 2 times 14x. 28x, and 2 times 1. Positive 2. So of course when we go to solve this, we try to get rid of one of the variables. The x's disappear. This time, however, we're left with negative 21 equals 2. Is that true? No, it is not. So the second possibility is it's false, or it's not true. So that means there's no solution. There is absolutely no number we can put in here for x that'll make this true. Okay, so let's see where this one takes us. Here, this one looks pretty ugly, but it's really not so bad as long as you go step by step. Here is our equal sign right there. So we're going to start out on the left side, combining what we can combine. Now we see more than one parentheses over there. So order of operations says we're going to go left to right. So left to right, this is our first parentheses. Anything to do inside of it? No. So we're going to multiply by 5. 5 times 4x, 20x. 5 times 3, 15. Second set of parentheses. Is there anything to do inside of that? No, so we're going to do what to it? There it is. Yeah, it's not 3. We're multiplying by -3. That operation in front always goes with the number that comes after it. So that -3 is really a -3. So we're multiplying -3 times 2x is -6x. And -3 times -1, +3. Very good. Now before we go over to the right side, let's see what else we can combine here. We've got 20x and -6x make 14x. And 15 and 3 make 18. So now we've combined, we've simplified everything we can on the left side. Let's go over to the right side. What do we have to do first there? The parentheses multiplied by 2. 2 times 5x, 10x, and 2 times 4. +8. Now we keep our +7x and our +1. What's next? Simplify. 10x and 7x make 17x. Next. 8 and 1 make +9. Good. Then what? Well, we've got an x on each side. Perfect. So we've got to take away the 14x. So we've got to subtract 14x over here as well. So on the left side, we're left with just 18. On the right side, we've got 17x minus 14x is 3x. Then we have +9 here. So now to solve, we would subtract 9. So 9 equals 3x. And yes, then we divide by the 3. So x equals 3. And just like always, you can go back and replace x with 3 in all the spots in that equation and verify that you get the same value on each side. Well, before we go any further, we are going to look at more complicated equations. But I want to look at an application of equations, which is going to require us to take a little venture into science. We're going to talk about solutions. Now, in solutions, there's always two parts. There's a solvent and there's a solute. The solvent is usually the larger portion of the solution. If we're thinking about a liquid solution, the solvent is usually a liquid. The solute is what dissolves into the solvent. By dissolve, it means it almost disappears. Now, you think of salt water, if you look at salt water, it looks just like regular water. The salt actually goes in and it disappears. What happens is you have the little particles of the solvent, in this case the water, that are sitting in there. The salt crystals, which are smaller than the particles of water. If you look at water, you don't think of there as being gaps between the particles, but there are. The little salt crystals go in there and they squeeze into the little gaps between the water particles. And as long as there isn't too much salt, as long as there's enough gaps to fit all the little grains of salt, the salt literally does hide in the water. You don't even see it there. One of the consequences of that, by the way, is if you had 400 milliliters of water and you add to that 50 milliliters of salt, you will not get 450 milliliters because the salt squeezes in between the particles of water. So what you're going to end up with here is less than 450 milliliters of solution. So later on, when we start looking at solution concentrations, that's kind of important because we usually, it's easier to measure solutions by mass or weight than it is by volume. So anyway, in these solutions, the solvent is generally a carrier. The medical term for it is actually a vehicle. It is carrying the medication to the patient. It is delivering the medication. The solute is generally the active ingredient. Or the medication. The generic term that we're going to use in this course is serum. So that is the item, the substance that we're really interested in, is that solute, that active ingredient. The amount of solute, again, that's the amount of the active ingredient in a solution, is the concentration times the amount or the volume of the total solution. The concentration is just the percent as a decimal. So if we have 600 milliliters of 8% solution, the amount of that solute, the amount of active ingredient in that solution is 8%, 0.08 times 600 milliliters, which is going to give us 48 milliliters. So whatever serum it is that we're using, whatever we're using for a solute, there's 48 milliliters of that substance in that solution. So how much 16% solution is required if we need to deliver 48 milliliters of serum of our active ingredient to the patient? Well, this one's going to be a little bit backwards. The amount is equal to the concentration times, I'm just going to put volume here. So we know the amount we want to deliver is 48 milliliters. Our concentration is 16%, so right there's a decimal, 0.16. So we're going to try to find the volume here. So how do we solve to find the volume? It's 0.16 times V, so to get rid of it, we're going to divide by 0.16, which is going to give us 300 milliliters is our volume. Does that make sense? If we mix two solutions, we're looking at the same solute, the same active ingredient, same serum, just different concentrations. So it might be 15% concentration salt water and 25% concentration saltwater solution. And we want to see what the final concentration is going to be. So here, let's say that we are going to mix 400 milliliters of 12% solution with 800 milliliters of 24% solution. Now, I'm always one to preach, do estimates before you start to calculate here. We know that our final result's going to be between 12% and 24%, because those are the two we're mixing. But before we start to calculate, which one do we expect it to be closer to, 12 or 24? The 24. Why the 24? Yeah, there's more of it. There's more of the 24% solution, so that's going to dominate our final mixture, and hopefully that will have more, it'll be closer to the 24 than to the 12. So now to mix these, to combine these two solutions, we want to find out what is the final concentration. Well, we're going to mix solution A with solution B to get a final solution. Notice I put amount A and amount B to get the final amount. Because what we're really focusing on is the amount of that active ingredient, of that solute. So the amount of that active ingredient in solution A, what's its concentration for solution A? It's 12%. So 0.12 times how much of it is there? 400 milliliters. Now I'm going to leave the milliliters out just to simplify the expression here a bit. We're going to add to that the amount in Solution B. Well, what's the concentration in B? 0.24. And the amount? 800. And that has to add up to our final amount. Do we know the concentration of the final amount? No, that's what we're looking for. So that's going to be X. Do we know the amount of the final amount? Yeah, we're combining 400 milliliters and 800 milliliters. Our result, we're expecting to get 1,200 milliliters. So now we have an equation written out here that we can solve for X. So 0.12 times 400 is 48 plus 0.24 times 800. I believe that's 192, correct? Okay. Equals X times 1,200. I'm just going to rearrange that to be 1,200X. Now we can combine the 48 and the 192. It's 240. Equals 1,200X. Our last step. Divide by 1,200. 240 divided by 1,200 is 0.2 equals X. So that final concentration is 0.2 or 20%. Any questions there? Okay. Well, what I did there is really backwards of what we normally do. We don't usually just randomly grab different amounts of different concentrations and mix them together and try to figure out what we're going to get. Normally, we have a certain concentration that we want, that we need. So let's say that we have on hand 32% and 38% solutions. We need a 34% solution. So my question is, how much 38% solution do we need to mix with 240 milliliters of 32% solution to create the 34%? So we're mixing two solutions together here to hopefully get our final result. Do we know the concentration for the first solution? Well, yeah, we know all the concentrations. The first solution is 32%. How about the second solution? 38%. Those are the two that we have on hand. Those are the two that we're going to be mixing together. And we want to create a final solution that is 34%. Do we know the amounts of any of those? $240 milliliters goes with 32. We're trying to find the amount of the 38%. So that's going to be X. Now here's the part that a lot of people find difficult. How much of the final solution, the 34%? Well, if we scroll back up here for a second, how do we get the 1,200? Yeah, 400 plus 800 gave us 1,200. The same thing down here. 240 plus x is going to give us 240 plus x. Or I'm going to write it as x plus 240. So my equation, concentration, 0.32, times the amount of 240, plus this concentration of 0.38 times the amount of x, has to equal, over here my concentration of 0.34 times x plus 240. .32 times 240. 76.8. 0.38 times x is just 0.38x. Nothing more I can combine on the left side. So we're going to go to the right side. We have to distribute through the parentheses. 0.34 times x is 0.34x. 0.34 times 240. 81.6. Now, just like some of the equations we saw, there's a variable on each side, so we're going to get rid of the smaller one, which is the 0.34x. Leaves us with 81.6 over there. We subtract 0.34x here, we get 0.04x over there. So 76.8 plus 0.04x. We'll subtract the 76.8. 0.04x equals 4.8. I know I'm flying along here, but I got like a half a minute left. So we divide out the 0.04, x equals 120. So we would add 120 milliliters of that 38% solution. We will go over more of these mixture questions next week, but I always want to get them in before, and we just lost the connection. Anyway, the pages, hopefully they get it off the recording, are 49 through 50, 1 through 43 the odds, that's just solving equations, and page 53 through 54, that is going to be on the mixture. So I'm going to put 1 through 15 so you can try more of those if you need to. Like I said, we'll go over more of these next week.